Hi everyone, this is the continuation of deadlock. In previous session we have seen what is a deadlock and what are the necessary conditions of deadlock. In that we have seen the four necessary conditions of deadlock, which is of mutual exclusion, hold and wait, no preemption and circular wait. And we got a conclusion that if any of these four condition is getting satisfied by a system, then for sure the system will enter into an deadlock state. Now we are going to see about resource allocation graph. RAG is denoted as resource allocation graph. In this, the RAG is nothing but it is an graphical representation of the system which consists of all the resources and processes which is currently being activated on that system. Okay, this obviously a graph is nothing but it is a combination of vertices and edges. Here the vertices are represented by V and the vertices consist of the process and resources. These are the two inputs which we will be using on the vertex, and the edges are nothing but which is the connectivity between the process and the resource. Here the active process are represented as P1, P2, P3 up to Pn, and the resource are represented as R1, R2, R3 up to Rm. Okay, these are the vertexes, and the edges are the connectivity which was established, right? There are only two edges available. One is an request edge and another one is an assignment edge. Request edge is nothing but when a process is requesting for a resource. For example, in this, the process Pi is requesting for an resource of Rj. Then there will be an connection from Pi to Rj. This edge is known as request edge. And assignment edge is nothing but when the requested resource is available and the resource is currently getting allocated for the requested process, then that edge is known as assignment edge. Here the resource Rj is getting directly allocated for the resource Pi. Since the resource Rj is currently free and it is not allocated for any other process, so it is getting allocated for the process Pi. It is one scenario. Or else if a process Rj is getting held by another process and after utilization it is getting released, and after getting released the resource Rj might be allocated for the process Pi. Whatever it is, the resource which is getting allocated for the process is denoted by an assignment edge, and the process which is requesting for an resource is denoted by an request edge. In this resource allocation graph, all the processes will be mentioned within circle and all the resources will be mentioned within a rectangle box. And if the resource is of single instance, then within the rectangle the resource can be mentioned. But if the resource is of multiple instances, then a dotted point or small rectangle will be noted in between the largest rectangle of resources. In this given slide, the second one indicates the resource with an instance of total number of 4 instances, which was indicated inside the largest rectangle. And further, the third one indicates the request edge from the process Pi to the resource Rj. In this situation, the process Pi might entirely allocated for the resource Rj, which is of 4 instances, or else the process Pi might be requesting for a single instance of the resource Rj. It is also applicable. And the process Pi which is holding the instance of Rj is indicated on the last graph. Okay, in this the only one instance of the resource Rj is getting holded by the process Pi. Okay, there is nothing but the third diagram is represented for the request edge and the fourth diagram is representation of the assignment edge. Okay, which I have seen previously. The edges consist of request and assignment, right? So this is the one which is mentioned here. This is the example of resource allocation graph. The resource allocation graph consists of the vertices of process and resource. Here there are three processes, P1, P2 and P3, and the resources are of R1, R2 and R3 and R4, and R1 and R3 are of single instance resources, R2 is of 2 instance resources, and R4 is of 3 instance resources. And there are multiple edges from P1 to R1 and R1 to P2 and P2 to R3, R3 to P3, and from R2 to P1 simultaneously R2 to P2. These are the edges available in this resource allocation graph. In this, the resource instances I have already discussed. R1 and R3 is of single instance, R2 is of 2 and R4 is of 3 instances. And the process which is holding is represented as, in this, the process Pi is requesting for a resource Ri which is already holding a resource of single instance of R2. Do you get it clearly? In this, the R2 is of 2 instances. In that, one instance is getting allocated for P2 and one is getting allocated for P1. So for representing a process P1, we can say it as P1 is holding R2 and P1 is requesting for an resource R1. In such a way, P2 can be said as P2 is requesting for R3 and it is already holding R1 and R2. And for P3, we can say it is R3 is getting holded by process P3. These are the explanation which can we understand from the resource allocation graph. So the RAG graph is nothing but, from studying that graph we can get an idea which resource is being held by the process currently and which process is requesting for that current resource and waiting on the queue.